So now let us discuss about binary tree. So in the previous videos in my playlist, you would see that I have created a binary search tree. You know how binary search tree looks like, right? And if you don't know, you can watch those videos. But I'm not going to discuss those things here because first of all, this video is going to be so much lengthy. So be patient because this is so much important topic. Here what I'm doing is I'm going to create a binary tree. Again, I'm mentioning it is not a strict binary tree, right? It is a binary tree. What is the condition to create binary tree? It should have a order degree 0 or 1 or 2. So this is my condition. So I will create a binary tree. For that, what are the requirements I need? So my requirements are, I need a queue. Okay, I need a queue that will store the address of the node, right? Node, because I'm using linked list, right? I'm using linked list. Imagine I need to create a tree with these elements. So let me create. Let us see how it looks like. So it will be like I need to create a linked list. Since I am using linked list, I am more specifically using double linked list. So it will have a left child, it will have a right child. In my previous video, I have said the representation in the video that named representation of binary tree. You can watch by using how array and linked list have made a how to represent the binary tree. I have said that, and here also I will do the same thing. I will use a double linked list, right? So I need to put the data here, right? Okay, I need to put the data here. So it should be having left child. So it will should have a left child. Let me give the value as 10. So it should have a right child. Let me give the value as 2. Then this 10 should have only a right child. It should have a right child. Let me call it as, let the data for this be 9. Since it has only right child, left child should be what? Null, obviously. Then this 2 has a left child. Here I had right child, now here I have left child. Let me give the value as 3. So I'll give this as 3. Then imagine this 9 as left and right child, and those values are 4 and 2. So okay, 4 is a left child and 2 is a right child. So you should be so much careful. My suggestion is, don't write anything, just watch the video, because it is somewhat complex to understand how this queue works. First of all, what I am creating this queue is, it is circular queue. That means this node will be connected to this node, like that. You can imagine like a circle, right? The queue is like a circle. So let me not show like a circle, but in code I am going to write a circular linked list, that is circular queue, and I will be explaining you the topic as well in the same video I am doing. Okay, now what I need to do, I need to uh, take a queue. I took the queue. Then what I will make is, imagine the address of this is 200, then this is 110, this is 105 or anything. In linked list, address can be created anywhere. That is normal, right? It is so much common in linked list, but still I will take like this. So 130 like this. So there is no certain pattern here. I'm just taking the values. So let me be random and take 160. Let me take it as a 200. Okay. Now these are the address, and this is again null, and this should be null, and this is also null, and this should be null pointer. So this is a linked list, right? So I have a stack. This stack, what it will store? It will store the address of this node. So it will store the address of this node. So it will store this address, right? And it is, first of all, it is like a array. it will have a size, right? So you can uh, use a double pointer for this. So in code I will explain you clearly how double pointer works. So now what I will do is I will take out the address. First of all, root node will be here. Imagine root node. By using, imagine, first of all, the concept is I have not created anything. These things I am just representing. Imagine I have to create this. First of all, I need to create root node, right? So root node should have a value 5. So I will create a node. First of all, how to create a node? You should need a structure. You should need a structure which has a left child, right child, and data, which you already know if you are following my videos. And even if you're not following, you'll be knowing that, because it is a standard procedure of creating node for a binary tree, or generally for tree. Okay, now what I will do is I will take a pointer now. Take a pointer, let me call it as a p. So let me again, I need a pointer of node type. I need a pointer of node type. So let me take the name of those pointer as p and q, and p and t. Let me take it as p and t. So I need you to focus so much at this step. So I will take t, and this one is to create a new node. Like I need to create a new node, then add a data, right? For this I am going to use t, and usually in my video I will be using t only. Then p, let me point p at the root node. Okay, I have pointed. Okay, please listen this carefully. Now this is a root node. I know I have created a node using root. Then I have included the value for, that is data of that root node, that is 5. Then I am pointing this pointer of node type at this root. Okay, now so what I will do is I will take out the value of, I will push this address into q. Okay, I will push this address into q. As soon as p enters this node, right, I will push this address to q, right? Okay, now what I will do is I will take out this address, right? I will take out this address. Now first of all, what is the address of p, where p is, right? Where p is, I will take this address, and you know that p is at 100, right? P is at 100. Okay, sorry for now. See here, I have 100, right? This is the address. So p is pointing where? At this address. So I will take this address, take out this address, and point p at this address. So this is a recursive process. So I will point p at this address that I removed from q. Okay, now what is p having? P having the address that is 100. Okay, now look at the ask for the person, that is user, whether you have left node. So if he don't have, what he will put, right? He will put -1. For example, when you are here, imagine p is here, p will move, p is here, and p will ask for left node. Here what you need to pass, right? You need to pass -1, representing that there is no element here, right? So if we don't pass -1 as in data, that means he need to create a left child. So for that, what I will do is I will take t, and I will ask the user for the data, right? Which data? Like 10 he will pass. So I will make t data as 10, and I will make t's left and right child as null, initially null. I need to just create, my objective is to create this one. So for that, after that, what I will do, is I will make p left point on this t, right? P left I will point on this t. Okay, p left, yeah, I'm pointing on t, right? Then what I do is I will put this address I will put it into Q. I will put it into Q. So I will put this address into Q. Now again I will ask the user whether this node has right child. Same thing I will do. Using T only I will create the node here by using T and malloc function, obviously, or in C++ I will use new. Then what I do, I will point P right child, R child, on this T, and this address I will put it this here. Okay, I have done this job. Then what I will do? Then I will, so my left and right child, it is clear, right? Then I will pop address from Q, because I need 110 here. I need 110 here, so I will pop this address. So when I pop this address, P will have what? So as I said earlier, P will be pointing to the address that I popped out. So 100 was that I popped out. So P will be pointing initially for 100. Now I am popping out 110 address. Imagine like a 110 address. Actually it will be some long values. So you know how address works, right? So we will pop out P. So no, when I will pop out the address, then I will point this P to this address. So let me take write P on to this address, right? On to this address I will. So P will be pointing here. So now ask the user whether P has left child. He will give you -1, right? He will give you -1. That means there is no child at all, right? Left child. Then you ask for right child. He will give you 9. Okay, he gave you 9. Then what you will do? Then immediately you should take this address into Q. That is what I said. Immediately, first of all, what you make, he will give the data, right? Then you make P right child, R child on T. So again, how do you create this node? First of all, create this when he passes 9. You create this node using T. Is recursive, all are recursive. Then T data should be 9. Left and right should be null initially. Then P right should be pointing at T. Then again take out this value of T. Then push it into Q. Okay, right? That is what we need to do. After that, you need to pop out the address again. So this time I have popped out 120. So immediately what you will do? You will make P point on 120. So P is pointing on 120, right? Then ask for left child. He will give you left child, right? He will give you left child, and that is 3. So again using T, I will create a node and I will make T data as 3. Then what I will make, and left and right as null initially, and here finally also it will remain same. Then P left child should be equal to T, right? Should be T. Immediately you do what? You push this address into Q. Okay, you have done. Now what? Now again pop out this address, that is 130. So P will come where? P will come to this 130 address, and this will go on, and the same process as I said, right? This will go on. So I think it is so much clear for you how it works. Before going to code, let me give you some what I'm going to do is, imagine. So let me go to code. So it will be after that I will explain you what to do, right? And let me open my code blocks. So, or should I do in online compiler? So let me use my code blocks. Okay, I will open the existing project. Okay, now I have code blocks. Then, so now I will create a include IOSTREM stream using namespace std, right? Then int main, right? Then before that, let me give you some overlook on Q. Q will is what? Q will have what are the features of Q, man? It has size. Okay, it has size. So let me write a structure for that one. So struct struct. Let me call it as Q. Q, and it will have a size, right? It will have a size. Then what it will have? It will have a front, means it has front. Then what it has? It has a rear. What are front and rear? It is nothing but the indexes. So it has a node. So this node I will create another structure. As I said, it will that node is that structure helps in creating node, right? So I will take a double pointer. As I said, I will tell you what is the use of this double pointer. Why I am creating double pointer? First of all, you know, right? What is this? This is a pointer. Or what is this? It is an array. So whenever, if you have observed that while sending the array to the function, right, and in the function you will be receiving that value, right? While receiving, you can receive the array in two ways, like int arr, like this you can receive, or else you can receive like this. That means pointer array is nothing but pointer, man. It is nothing but pointer. Why? Because the variable of the array, like array name, what it stores? It stores the address of the first element. So star q is to create an array. Another star, why I am using? Because it need to store, it need to point to the address, right? What pointer does? It will point to the address. So another star helps in pointing to the address. One star helps in creating the array. So another structure what I need is node, right? Again, it has data. Normally it has node type left child, 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 and node type right child, rchild, child, right? So let me copy this and paste this in. Okay, I'll paste this here. Okay, I created a structure for Q and node. Now for Q, right? For Q, you need to create Q. First of all, let me not focus on this node. Let me focus on Q. So let me push this here. So you need to create Q, right? So let me call void function and create. What you will create? You'll create Q. So person will pass struct type, that is Q, or you can take in C++, you can simply take Q, then star Q, right? I need to create a Q. So he will first of all create a Q, then in order to specify the size and front rear, he is going to pass you that Q variable, and he may pass you like size is z. Let me take it as z. So what you will make it? You will make size SIZD as, that is Q size, right? Q size is Q. He will send you Q, some variable of Q type. Why he will send? in order to specify, give some specification for this. So what I will give size, I will give as size. So you will also send me size also. So directly I will take the variable name, that is I will take that size what he have sent. Then I will make, so since I am creating queue, initially always remember I am talking about circular queue. So in any queue, this is so much important. This is queue, right? This is circular queue. So imagine it has some nodes in it. It has some size, and when front index, it has some index, right? When front index and rear index are at index 0, imagine like this, front and rear are at index 0, then what? Then that queue is empty. Means just now you have created the queue. So how to create the queue then? Make front and rear as 0, that's it. So you have created a queue. So rear will move front, always remember, front will be here. Then imagine I need to push into queue, some address I need to push, right? That is what I am doing. That is what I explained you. So imagine front is here. How to push the rear? How to push the address into queue? You push the rear first. Rear should be here, and you fill the address here. Then what? Again you push the rear, right? Again you push the rear and add the address. So one condition is there. So imagine your rear has reached this one. So that means what? The queue is full, right? Queue is full. How to check whether that is your rear has reached this here? So I will make some mathematical function usage. So that is, imagine you have given the size as 100. This is the size of the what? Of the queue. So what you will make is queue rear, 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 or simply let me make generally, if rear, that is the index which is rear is pointing, plus 1, and if you take the remainder of that with the size is said, if it gives you front index, then what? Then queue is full. If this happens, then queue is full. Let me explain you if you didn't got. So queue is full. Let me see out. The queue is full. So with an example I will explain you what is happening here. So let me imagine my size is 100. So okay. So if it starts from index 0, at which point it should end? It should end at 99. Okay. Rear is at 99. Okay. 99 plus 1 is what? 100. 100 percentage 100. That means remainder of 100, right? So when you do 100 divided by 100, what will be the remainder? Obviously the remainder will be what? It will be 0. So front is already at 0. So front is 0. Whatever your key asking is as rear is as at the end. What you need to do? Queue is full. So you need to reply this message to the user that queue is full. Okay, that is how it works. And again, how do you push queue? Again, this is one part you need to understand that I am not going to explain you again while writing code. Or in code, what I do is instead of rear, I will take queue dot rear because it is a structure, right? You know how structure works. Like that I will do. After that, how to push rear? How do you push rear? So what I will do is rear should be equal to REAR, rear plus 1, then percentage size. This is how I will push. So you would be understanding this one. So I will just how to increment the index, you just do plus 1. But why I am doing size? Because it is a circular. Again, right? That is the reason. So if I am here, imagine I need to push front. Actually, I will push the front. I will push the front in the code, right? Even I will push rear also in order to enqueue. enqueuing, I need to push the rear, right? So this, since it is circular, and as I explained you this one, this should be easy again. You need to do percentage size, because you need to go to next circular. If imagine you are at index 2, man, index 2. So 2 plus 1 is what? 3. 3 percentage 10 is what? 3 percentage 10 is, sorry, 100. The size is 100, right? It will give you 3 again. So it is working as usually. But when it goes here, right, 99, it will give you the next position. That is why I'm using these types of these things. Okay, let me go and code. So I have given size as z. Then what I will make? I will make front, front, front. I will make rear as 0 normally, as I explained you earlier, right? Then what? Then I should make some memory in heap, right? In heap. How do you do in C? So it is easy. I will create of node type, again of node type. So since I am using node here, let me define node before Q itself. Okay, now it is a node type. Usually what you will do in order to create a single of if this is a pointer, just a pointer, imagine it is not a double pointer, imagine it is a pointer. What would you do? I will show you a trick. Malloc, then size, they have given you size already, right? Siz is size, then multiplied by, you need to do size of node, right? This is what for a single pointer you will do. So since it is a double pointer, you simply add 1 star here, then again 1 star here. So this is a shortcut to remember. Okay, this is created, I have created. Now how to enqueue? How do you enqueue? You will move rear, right? So same thing I will do here. Enqueue, QEUE, enqueue, then I will take Q. I should take Q, right? Definitely I should take Q, because I am dealing with what? I am dealing with front and rear, which are there, which is the property of Q itself. Then what do you need to enqueue? Like, what do you need to enqueue? I need to enqueue not a key. I don't need to enqueue inside Q. What you are enqueuing? It is an address, right? Address. So that means you need to take what? It is not an integer type. It is a node type. Right? It is a node type pointer. Okay. Let me take it as X. Okay. Now what? I need to enqueue. Then if Q, right? Q, REAR, rear, plus 1, as I explained you earlier. Not going to explain you again. So if it's multiply percentage of Q dot size, if it's become equal to Q dot size, that is front, then what you do? You print me a message that the Q is the Q is full, right? Okay, then else what you do, or else what you are going to do, right? Or else I need to move rear first, right? I will move rear first. Okay, move REAR. How to move rear? I already said you how to move rear. REAR, rear, plus 1. Then what? Modulo operation Q of size, right? The size, that is size. So then you need to add that element, right, after moving. So that Q REAR, right? Actually you need to use this array, right? This is actually Q. It is an array of, it is like an array, you can imagine. So Q, then index you need to put. Index is Q rear. This is nothing but integer type. It is just a position, that is index, will be equal to X, right? Will be equal to X. This node address I am putting here. So I need to dequeue, right? I need to dequeue, right? I need to dequeue. For that I will give the function name as dq. Okay, now again, while dequeuing, what I will return is, I will return a node itself. Let me return a node, right? I am returning a pointer, right? I will return a pointer to what? To p, as I explained. In code I will write further. Okay, dq. Now what? Q, I will again take up the q, star q, then what? Then if, right? I need to return node, right? So let me take some node called x and let me make it as a null, right? Then if q front is equal to q rear, that means what? I already said you that q will be what? The q is empty, empty. Else what? Else what I will do is, I will return x. Before that, what I am going to make is, I will push this front, f r o into front, and I will make it as q front. Again, I said how to move front first, front o into front, then plus 1, then multiply and modulo of q of size, as I said you earlier. Then I will make x is equal to q of that q, then q front fro into front. So this is what I did. Then I need to return, right? I need to return x. So this is what I did. Now let us see what I need to do. Like, I need to create a function. For what? In order to create this tree, I need to create a function, right? Let me create function for that. So first of all, what are the requirements for creating the function? So I need to take root node, and these things I will do here itself. After that, I will write the int main function. So let me complete this one first. So that is, I will create a void, because I need to just create a tree, right? Create a tree creation. Let me give create tree. Okay, then what I will take inside, I will take nothing. Then I will create a node, right? I will create a node of p. Why p? It will point to root. So before that, I need to take a root as what? First of all, I forgot this thing again. So I need to take root, right? Root as a global, right? It is of node type, so I am taking like this. It will be null. So either what you can do is, you can simply take this like this, root is equal to null. This is also valid, but let me do this compressed version. So now what? Now I took p. Why? It will point to wherever. See, I had explained you there, right? The same operation is done by this p also. Now I will take t in order to create a node, new node. I will take x to ask the user to put in the root value, right? I need to ask the user putting the root value. Before that, I should need to create a tree, right? As I explained you, to create a tree, I should call this create function. So let me call this create function. So what I will pass? So before that, let me create this q, right? This q is there now. I will create this variable. So that variable is q. So while I will send this q to this function, so that it can create everything and come. So I will send q. Then what I will do? I will also send this size. Let me send 100. So I have sent this size. Now I'll ask the user. I will ask the user enter the root node. Enter the value of the root node. Value of root node. This is different from see, creation. Further creation will be easy because it is iterative process. That's it. So inline, I will not do anything. So okay, I'll ask for x. Okay, then I have created root node, right? What I will make is, I will point this I will make a new node, means I have to create, first of all I need to create root in heap, right? So for that I have created root in heap. After that I need to put root data as what, x, right? As x I will put. Then root L child and root R child is what will be again null. Okay. After that I need to do enqueue, right? Means I have to enqueue root inside root address. As I said, I will enqueue this root address. So I will pass that queue and I will pass root itself, root node, so that it will take up the queue and it will take up the node. Then it will enqueue the address, right? Now it is iterative process. Everything creating root node is only separate process. So everything is same. Now what? Now see, another thing is I have created in C++, so I used this thing. So if you are creating in C, what you do is normally, you know, right, what to do. Root node, then malloc, then size of node. So if you give this, it should work. In C you should give, obviously you should give struct struct like this you should give, and here also you should give struct. So again in C++ you can just give node, it will also work, it will work. So let it be there in C. I will mention in C. Okay, then what? Then while loop I will start. While empty, that is queue is empty. Check if it is queue is not empty, right? Is empty. I need to write function for that also. Is empty, empty. If it is not empty, it should this function should return what? I will send queue. It should return me true if it is empty, right? It should return me true if it is empty, right? If it is not empty, I will get inside, right? If it is not empty, then only I will get inside. That is what the meaning is. So let me write the function for this. What it returns? It returns int. So is empty, empty. Then what it will take? It will take, normally take CUE q struct q. You can write in C++. Again, sorry, in C and q. Then I will return what? I will return if q front is equal to q rear. So if it is true, then it will return 1. It will return 1, telling me that it is empty. So if it is not empty, that is why I added this one. If it is not empty, I will take a pointer, man. I will take a pointer. Let me, I already defined this pointer here. Let me point this to dq. I will dq means I will, now what I do is dq. What it, this dq will return me? This will return me address, right? So I need address at p, right? As I said in theory, I explained. So return me the address, right? Return me the address. So he will return me this, like as I said, he will give me this thing, right? Will give me this thing. P will be pointing there. Then what? Then I will ask the person, enter the left child of what? Of p data. Of p data, you enter the left child, right? I created. Let me give end line, right? Enter the left child of this p data, right? Okay. Then or else let me make an equal to symbol here. That will be more accurate. So I will give some gap. Okay, it should work. Now what? After if so I will create int x, like I will take a variable and I will ask the user to give the x value if x isn't equal to -1, then only I will proceed. If it is equal to -1, why to create a node at the first place? So again, t is equal to, I will create a node. So t is equal to new node. So t data should be what? It should be what, x. Then t L child should be equal to t right child, as I explained you in code. So after that, p L child should point on what? It should point on t. So right, so after that, what you need to do? You need to enqueue that address. Same thing what I did, this step that I followed. So enqueue this address, man. Which address? So what I need to pass? I need to pass uq. What you need to enqueue? You need to enqueue t, right? Now I'll ask him to enter the right child, right? Instead of asking him, I'll just copy this one. I will just copy this one because it is the same process. I will ask for the right child, RIGHT, right child. Then again same thing, x. And if is then data r child should be, again this is p right child should be what? Should be t. So that is what change I will do. So I have simply created, all thing is over. Now I need to print the data, right? For printing the data, I will use pre-order. So you should be knowing what is pre-order, because in previous video in binary search tree, I have made this video on pre-order, in-order, post-order. So if p isn't equal to null, then what you do? You need to print. You need to print what? You need to print data. I will use recursion for this. So normally that is the best thing. Then pre-order, then I will pass left child, then pre-order, then I will pass right child. In previous video in this playlist, if you search, you will get detailed explanation of this recursion. Then what? Then what? I will create a tree. First of all, I need to create a tree, right? So I will pass this thing here. I will just call for this function, right? I will call this for this function. Then what I will do? I will pre-order by sending what? I will send the root. Then I will tell to pre-order. Then I will return 0. Then it should work, I think. Let me see what are the error that I can get. So let me run. So again, I did some error. I have not used semicolon. Then let me run. Then again there is some error. Q front is equal to, again I have missed this thing here. So let me run. So again there is some error. That is, if you need to error. Okay. So it is, I am not taking it as a star, right? Means pointer I am not taking. So you need to use what? Dot operators. That is the basics of structure, right? Then I will run. So I am getting again redeclaration of x. Okay, if it is redeclaring, so let me remove this x itself. So since I have created already x, right? So what is the need of doing x again? So it is not showing any error. I think it should work. Hope it will not crash. It will take some time. Then I think it should have been. So let me see what. Okay, now it should ask me root, right? It should ask me root node. So let me wait until it asks. So it is not doing anything. So I've created, so it is asking. Okay, in the previous what I have given the values, there is same values. Let me give 5 10 2. Okay, 5 10 2. Let me take this here. Root node is what? 5. Okay, left child is what? 10. It has left. Okay, right child is what? 2. Okay, for 10 what is the left child? It is -1. It is -1. Okay, right child is what? 9. Okay, for 2 left child is what? Left child is 3. Okay. For 2, right child is what? -1. It has no right child. Okay. For 9, left child is what? 4. Okay. Then right child is what? Right child is 2. Okay. For 3, it has nothing, right? So -1, -1. For 4, it should be -1, -1. Then for 2, there is nothing, again -1, -1. So pre-order should work now. So let me trace this and let's see whether. So how do you trace pre-order? You will write like this, right? You should write like this. Then you traverse here. First touching is 5. Okay, 5. Then you are touching what? 10, 10. Then what you are touching? It is actually null, right? You should be touching. Okay, it will go here. Then it will come. Okay, 9. Then what? You will be touching 4, 4. Then you will go like this here. Then you will touch what? -2. Sorry, 2. Then after that you will go here. You will go here. You will go here. Then you will touch what? This is 2 again. So I took 2 twice. 2. Then what? You'll be touching 3. So I think you should get this result. So you are getting 5, 10, 9, 4, 2, 2, and again 3. So okay, this is how it works. I have explained you how to create binary tree. So before going, please check out this playlist about tree. I have completed most of the topic. That if you complete this tree, I guess you don't need to study anything about tree. I have completed all theory, all even all the recursion I have explained manually by writing recursive tree. Please check out the playlist. And if you learned something in this lecture, please like this video and please subscribe to this channel. So thank you.